Okay, so we're going to look at a set of information here about lines and angles. And then we're also going to look at information about angles that are formed by what are called parallel lines and transversals. So let's start with just simple stuff about lines. If I have two lines, that's not very good. Two lines that are coplanar, so both of these are in the plane of the screen and they do not intersect. We call these parallel. The reason why we have to have that word coplanar in there, so it's possible to have lines that are non-coplanar that also don't intersect. So imagine like you have a box. And so here's my box. Right? And if I look at this line here, right? So the one on the top, and I look at this line here, right? So this line here and this line here, one is in the lid of the box, one is in the bottom of the box. These lines will never intersect. And yet, they're not parallel in that they don't exist in the same plane. Right, coplanar, there we go. So what we call these lines is skew. It's a great little word, skew, which just means that they are non-coplanar. All right, so there's parallel, there's intersecting, and then there is skew, which are non-coplanar lines. And because they're non-coplanar, we also know that they're not going to intersect. Okay, so two lines either intersect, they're parallel, or they're skew. Now, what happens if I kind of have three? So a common idea here is to have one line here, which we're going to call J. Another line here, which we'll call K. And then we got a line that goes across them, and we're going to call that line T. Okay, when that happens, with two lines being cut by a third line, that line we're going to call a transversal. So the line that's cutting the other two lines is what we call a transversal. Now we're going to number these angles 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if you think about what's going on here, the space between these two lines we call the interior, and the space outside we call the exterior. So this is exterior, this is exterior. Okay, so we're going to come up with a whole bunch of angle pairings. The first thing to note is, okay, inside, so interior, the ones that are on the opposite side, like 4 and 6, are an angle pairing that we're going to refer to as alternate interior angles. Okay, so 4 and 6 are alternate interior. They're in the interior, but they're on opposite sides of the transversal. So those are what we're going to call alternate interior angles. You have another pair of them, 5 and 3 are also alternate interior angles. Okay, so angle 2 and angle 8 are what we're going to call alternate exterior angles. Okay, so 2 and 8 are alternate exterior angles. They're on the outside, they're in the exterior, and they're on opposite sides of the transversal. So they're alternate and exterior. Okay, so another set that we have here would be like 3 and 6. So if we look at 3 and 6, we're going to refer to those as, so let's get a little space here. We're going to call those same side interior angles. Okay, so they're both in the interior again, but now they're on the same side of the transversal. And finally, the last type of angle pair would be like 8 and 4 here. So one of them's in the interior, one of them's in the exterior, but if you look at the intersection, they're in the same place. They're both like down and to the left, right? Down and to the left. We call those corresponding angles. Okay, so 4 and 8 correspond to each other. 1 and 5 are both up and to the left. They correspond. 2 and 6 are up and to the right. They're corresponding angles. 3 and 7 are down and to the right. They are also corresponding angles. So 4 types of angle pairs here. Alternate interior, alternate exterior, same side interior, and corresponding. So in the last drawing, we just had 2 lines and a third line cutting through them. In this one, we're going to do something different. We're going to make those 2 lines parallel. Okay, so 2 parallel lines, we're going to cut them with a transversal. Okay, so now the lines are parallel. They are in the same plane, but not going to intersect. So we're going to number these the same way we did before. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we still have these 4 types of angle pairs. We have corresponding angles. We have alternate interior angles. We have alternate exterior angles. And we have same side interior angles. Okay, so we get a postulate. So if we look at like 2 of the corresponding angles, let's say 1 and 5 are corresponding. If you were to like slide this line up to there, it would be very clear that 1 and 5 have to have the same measure. So we get a corresponding angle postulate, which tells us that corresponding angles, when the lines are parallel, are congruent. So like 1 and 5 are congruent, 3 and 8 are congruent, 2 is congruent to 6, and 4 is congruent to 7, all by the corresponding angle postulate. Okay, so we're going to get an alternate interior angle theorem. Now, pretty clear here that if 1 and 3 have to be congruent because they're vertical angles, and so are 5 and 8. So if I look at the alternate interiors, 3 and 5, 3 has to be congruent to 5. So does 4 have to be congruent to 6. Now, we'll prove this theorem formally a little bit later, but if I have alternate interior angles, 2 angles that are in the interior and on opposite sides of the transversal, they also must be congruent. Likewise, alternate exterior angles. We're going to get an alternate exterior angle theorem, which tells me that if I have 2 angles on the outside, but on opposite sides of the transversal, like 1 and 8, or 2 and 7, those pairings are also congruent. So, corresponding congruent, alternate interior angles congruent, alternate exterior angles congruent. The last one are same side interior angles. Now, 3 and 6 are definitely not congruent. This one is an acute angle, that one is an obtuse angle. These are not congruent angles. However, 2 and 6 are congruent, and 2 and 3 form a line, which means that 2 and 3 have to add to 180, which would mean that 3 and 6 also have to add to 180. So angles that add to 180 are what we call supplementary angles. Okay, so we have angles that add up to 180. So these are supplementary. And that's going to give us, again, another theorem. We're going to call that the same side interior angle theorem. Okay, and it's the weird one, but it's easy to remember. It's the only one that starts with S. Same side interior angles, supplementary. Everything else is a congruence theorem. All right, so we will leverage this a little bit later on, and we'll do some proving with these theorems. All right, so we're actually going to prove one more theorem, and then we'll be done here. Okay, so this is an unnamed theorem, but it's just a fact that we're going to want to have around. If a transversal is perpendicular to one parallel line, one of two parallel lines, then it is perpendicular to the other one also. Okay, so let's get a drawing of this. I have two parallel lines. I have a transversal, which is perpendicular to one of them. So we'll call this one L, and we'll call this one K, and we'll call the transversal T. And so let's see. We're going to be given the if part, right? So we're going to be given that basically T is perpendicular to L, and that T, it's not T, L is parallel to K. We want to prove that T is also perpendicular to K. So we're going to build this table of statements and reasons to try to show that that has to be true. All right, so our first statement is pretty clearly, that's ugly. Our first statement is pretty clearly that T is perpendicular to L. And how do I know that? Because it's given. All right, our second statement here is then, let's make this angle 1 and make this angle 2. And it's that the measure of angle 1 has to equal 90. And why do I know that? Because these are perpendicular. So this is what it means for have a definition of perpendicular lines, right? You have to have a right angle there. So that angle must equal 90 degrees. All right, we also know that L is parallel to K. That's also been given to us. Okay, so that's pretty straightforward. And, well, let's see, 1 and 2, these are corresponding angles, which means that they have to be congruent. So the measure of angle 2 has to also equal 90. This is what we're going to call the corresponding angle postulate, right? It tells me that if the lines are parallel, boom, then they have to be equal in measure or congruent. So finally, I can say that T is perpendicular to K because, again, if this is a 90-degree angle, these things have to be perpendicular because that's the definition of perpendicular lines. Okay, so a quick review of ideas. If I have two parallel lines cut by a transversal, then the alternate interior angles have to be congruent. The alternate exterior angles have to be congruent. The corresponding angles have to be congruent. And the same side interior angles must be supplementary. Finally, if I have one that's perpendicular here, that doesn't look very perpendicular. If I have the transversal perpendicular to one line, it also has to be perpendicular to the second. All right, so there's a quick summary of what's going on here, and we'll go from there.